if you can share that in the chat.
Shall we get started? In the interest of time. Perfect. Well, good morning, everybody. To everybody here on the East Coast. Good morning to you. Good evening, wherever you are. Thank you so much for joining us. My name is Aaron Beydoun. It's a pleasure to welcome you all here today as we introduce Professor Wolfram Schlenker, the newly appointed Ray A. Goldberg Professor of the Global Food System at Harvard Kennedy School. We're also really glad to also welcome Dr. Ray Goldberg, who's here as well in attendance. We're going to briefly introduce ourselves and our SIGs, and then we'll introduce Professor Wolfram. So as I mentioned, my name is Aaron Beydoun. I'm the president of Harvard Alumni for Agriculture and Food, which is a shared interest group at Harvard, representing approximately 2,000 alum from across the various schools at Harvard. Our mission is to advance knowledge, foster collaboration, and strengthen connections amongst the alumni working in all sectors of agriculture and food, and of course, bridging a connection between the alumni community and the on-campus community. Through networking, professional development, continuing education, we provide a platform for alumni to exchange ideas, share expertise, network, and most importantly, drive innovation in the agri-food space. Look forward to having you join us. We're also co-sponsoring today with Eleanor and Harvard Alumni for Agriculture and Climate. Climate. So if you could please introduce yourself.
Thank you. So I'm Eleanor Powers. I'm one of the co-founders of Harvard Alumni for Climate and the Environment, as well as its co-director of programming. HACE is the only university-wide official SIG or alumni shared interest group that is exclusively focused on climate and the environment. We were started approximately 4 to 5 years ago. And have now grown to over 3,500 validated members worldwide. And we do programming around taking education, taking action, and community to support people who are taking action. And we should have our links posted in the chat there. If you're not a member, please join us, as well as our different communities that we have also provided links for. Thank you for joining us.
Wonderful. Thank you, Eleanor. And thank you for joining, everybody. I'd like to now introduce Professor Wolfram. It's a pleasure to welcome you and to welcome everybody again to here. Professor Schlenker's research lies at the nexus of climate change, agriculture, and economics. He has extensively studied many areas of profound importance to our alumni community and many of the people here in attendance today. As an example, such as how temperature extremes and weather variability can affect things like agricultural yields. His work also delves into the socio-economic consequences of climate change, including its influence on migration patterns and food security. In addition to his new role at HKS, Professor Wolfram is a research associate at the National Bureau of Economic Research. He's also a research fellow at the Center for Economic Policy, and he serves on the board of reviewing editors at Science. He joins us. He was previously a professor at Columbia University, with the School of International and Public Affairs, where he was the co-director for the Center of Environmental Economics and Policy, and also co-director of the Energy and Environment Concentration. He holds a PhD in Agricultural Resources and Economics, Resource Economics from the University of California, Berkeley, and a Master of Engineering and Management Sciences from the University of Karlsruhe in Germany, as well as a Master of Environmental Management from Duke University. We're honored to have him today to share his insights and to welcome him to the Harvard alumni community. And I also equally want to welcome Professor Ray Goldberg, who's also here. Please join me in welcoming both. Thank you.
Thanks so much for the introduction. Very pleased to be here. It's very exciting to have Ray on the call as well, although it makes me a little bit nervous, but it's been fantastic. I just joined the Kennedy School this past July. Been teaching in the economics department, co-teaching a PhD level class last semester, and this semester, I'm teaching for the first time food policy. I saw that Pete is on the attendant list too, who's generally basically volunteered himself to be a guest speaker. So very much looking forward to having alumni here involved in what I teach the current crop. The food policy class also turned out to be very interdisciplinary, which I really appreciate. There's people from the business school, there's people from public health, from all over campus, from biology coming and sitting in. So it's been a great pleasure. So for today, I want to first give a little bit of an overview of some of the work I've done specifically on agriculture and climate, that component. And then I think Eleanor will moderate some questions for the first half. So let me jump into this. So for the outline, I want to first give you a bit of a motivation for whether climate and agriculture is still important, the history, whether it's still in the current, and highlight some of the findings that I've done in my work and giving you an outlook for the future. So there is a long history showing how human societies have been very much interlinked with climate and agriculture. This is a science publication from 2011, reconstructing climate in the Europe over 2,500 years. And you see at the bottom in the red lines, these temperature anomalies. And throughout history, this is not necessarily causal, but there is this very strong co-occurrence of basically cold temperatures in Europe, yields not being very good, and society falling in a bit of a disarray. So, there's one paper highlighting that witch trials really spiked during the Ice Age, and whenever yields were very bad, somebody had to look for somebody to blame. And so they started, saying the bad weather was related to somebody's witchcraft. There were, by today's estimate, up to 40,000 people killed because they supposedly negatively influenced the weather. When the French Revolution started, again, wheat prices doubled to tripled within 3 months. It led to a lot of unrest. It's also been argued that this led to the French Revolution, among other factors, but climate being one of them. And the beheading of Louis XVI, the last king of France. Just around that time, with all the famines, we also had the famous book by, the essay on the principles of population by Malthus, where he outlined a pretty dire view of population growth and food security, arguing that agricultural growth could be at most linear, while population grows exponentially, so there will be many famines going forward. Now, fortunately for us, that hasn't panned out. We actually have had exponential growth in agricultural productivity. It's been actually one of the sectors with the highest productivity growth of any sector post-World War II in the United States. And so I'm going to talk a bit more about the role of climate, environmental factors, and so forth today. But nonetheless, while we have made big progress, weather is still a very important factor for agricultural yields. So 2012, we had the big heat wave over the US Corn Belt. Yields dropped by more than 20%. So here see a picture of that. It was in the news. There was also recently the heat wave in 2022 in India that led to a big shock in wheat yields there. And as a result, the Modi government basically put on an export ban. That obviously had the effect that if you're not allowed to export the wheat anymore, that the local prices in India actually didn't rise as much. But you created a bigger problem for the remaining countries which used to import your wheat, which now seen a big increase in the price. People estimate this to be about 6%. Just last week, I don't know whether you saw that, there was a big call by 150 Nobel laureates and winners of the World Food Prize, arguing that we basically need this moonshot effort to avert global hunger by investing in modern, new breeding technologies or come up with the next green revolution. It was heavily featured in the media and it includes a very famous Nobel laureate arguing for this. So I want to start out by giving you a bit of a background of recent trends in production and food availability, and then what, again, I contributed to that. So to set the stage, might be good to just review where we are on food prices. We've seen inflation and food prices being highly salient in the last election in the US as well. So where do we actually stand? How much progress have we made? And so forth. So if you look at the United States, so we have data from the census going back to 1866. You see there's two very distinct periods. You plotted here in red on the left axis, basically corn yields over time. You see that they've been pretty stable over time until about 1940. They go up and down as the weather is good or bad in a particular year, but it's a pretty flat around a constant in bushels. Ever since 1940, we see this really remarkable, almost linear increase over time. And, that's with the start of the Green Revolution and a lot of modification to how we do agriculture, we've gotten much more productive. This has been going up by almost a factor of 7 to to the 2024, the last year in this data from last year. Now, if you fit this trend, again, you see that before 1940, most of the increase in production came from basically increasing the area that we planted. Because we got the same amount of yields out per acre, so we could only increase the acreage to increase production. Since 1940, that kind of completely flipped. Now we sort of see a big increase in the intensive margin, how much we get out of each acre, and the area sort of started to stabilize. If you plot this in logs, in blue, that's on the right axis, the only reason why I do this is basically to show you that then the deviation from the trend become percent differences. So the first one was levels in red, the blue one is in percent. And so you see, for example, here exactly those events, 2012, the 20% drop in the blue line. You also see 1988, which had the big floods, and then 1936, which was basically right after the Dust Bowl, where there was a lot of extreme heat. And these are sort of the years with the really large, significant percent drops in corn yields. And the takeaway here is that even though we've made a lot of progress in average yields and a sevenfold increase, the variability is pretty much the same in 2024 as it was in 1940. So the amount of variability around the trend in percent term is remained rather constant. So weather is still a crucial factor. This green revolution is not just for corn, which has seen the largest one. This one plots the other three stable commodities. So in green is rice, in blue you have wheat, and then in black you have soybeans. They haven't gone up quite as much in terms of technological progress, but they've also risen substantially since 1940. And again, you sort of see these fluctuations around the trend that takes off after 1940. So what is then this implication of this technological progress since 1940? This is now plotting prices, log prices. So basically it's, again, percent changes over time, inflation adjusted. You see again how this was very stable before 1940. It's fluctuating around, what happened. You see again the Dust Bowl in 1930s where the prices go up and down a lot because of shortages. And then you see sort of the green revolution from 1940 onwards, where basically there's a strong downward trend to about 2000, when it sort of starts to reverse. And that's sort of what I guess worries some people nowadays. Again, this is not just true for maize, it's also true for wheat, for rice, or for soybeans. So you see this downward trend from 1940 to 2000. We basically had production increases outpace consumption demand increases. As a result, prices in real inflation adjusted terms dropped. But then since 2000, sort of that kind of reversed. And that's sort of what worries some people, that with climate change, increased population and so forth, we're going to sort of again enter in a world where food becomes scarcer. This is sort of just plotting global production across those four commodities for the whole world now. This is not just the US. And to make this more easily interpretable, what I just did here is I converted each bushel or center weight of a particular crop into calories and then plot how many people you could feed on a 2,000 calorie a day diet. This just makes the trillions of calories more easily interpretable. And again, there's been this big upward trend. And for comparison, you can plot the population. And again, you see that the increase in agricultural raw commodities is basically outpaced population growth. That's why real prices fell. I should mention that those four stable commodities, soybean, rice, wheat, and corn, they constitute between 2/3 and 3/4 of the calories that we humans consume, either directly because we eat, bread that's made out of flour, or indirectly because we eat meat, which is fat soybeans. So those four are really sort of the four staples that sort of feed the world. The US has always been a remarkably big, I think many people are not aware, player in this market. So this is sort of the 60s, the beginning when FAO starts its data. This is the most recent years for which FAO publishes data. 23 was the last one. And you see that the United States has only been overtaken by China in terms of production in calories from those four stable commodities. India, which I showed you, had the wheat export, is also a big producer. Brazil and Argentina have greatly expanded since the 1960s. So they're now also becoming some of the breadbasket. And you see how the USSR has split. It's now Russia and Ukraine. And that's also another story I don't really talk much about today, but it impacts the whole geopolitics and dynamics. Okay, so let me then talk a bit about my studies and sort of what I've sort of particularly looked at. So Aaron already mentioned at the beginning that one of the things I sort of estimated was the effect of temperatures and yields, and then what the implication for climate change is. So one study we did, and that's sort of one that got most of the attention is that we constructed really fine-scale weather data over exactly the location where crops are grown, looking at the whole distribution between min and maximum temperatures, while people before have mostly only looked at averages. And that was important because what you see here in blue is basically the distribution of temperatures that crops experience over the growing season. And when you then look at how it impacts crop yields, there's sort of these three parts. Below 10, there isn't much growth. Between 10 and 29 degrees Celsius or 84 degrees Fahrenheit, you have approximately linear increases in yields. And then if you go above 29 degrees Celsius, you have this really sharp decline. That's a remarkable, robust, and consistent finding across countries, regions, and so forth. And so that basically drives then everything with climate change, where we shift more of the temperature distribution in the upper tails. So if you believe this research, the optimal temperature you should have at corn, for example, would be constant exposure at 29 degrees Celsius. If you're 1 degree below, it's not good. So if it's too cold, it's bad. If you're 1 degree above, it's not good. And there's a huge asymmetry. And that's sort of what drives all this climate impacts. And what we've seen in 2012 with the heat wave is that being 1 degree above this optimum is about 10 times as bad as being 1 degree below it. So as you shift temperatures into the upper tails, that really reduces your yields. So again, this sort of has been verified in many other settings. But to sort of give you a very rough idea of climate change, this is not an actual climate change. It's just sort of a toy model here, to be clear. If you just shift this 3 degrees Celsius up the distribution, so the green one is basically saying I make every temperature 3 degrees Celsius warmer. It's non-uniform, more complex, but it sort of drives down the point. So this is just a hypothetical example here. Then you can take the difference between the blue and the green histogram. You sort of see you have less cold temperatures, which is good. You have more of the optimal temperatures are of 29, which is good as well, because that's sort of the optimal growing. But then you get a whole mass here in the upper tail, where you basically have a lot more mass here where temperatures are sort of really being hammered. And that is basically what drives all of the really negative effect of climate change, is this more extreme temperatures that you basically experience in the field. And so if you just look at how much temperatures exceed 29 degrees Celsius, 84 degrees Fahrenheit over the growing season and add that up and completely disregard what happened below, you can explain more than half of the year-to-year variability in corn yields. So it's really like this extreme heat that's very hard to adapt to, and that's predicted to increase with climate change. So whenever you estimate a statistical model based on historical data, there might be this question whether modern crop varieties are just getting better and better at withstanding heat. So it might be that, I calibrate my model by data from 1950 to 2010 or 5, where we originally used in the study. And nowadays, with modern biotechnology, that's just no longer accurate because crops are better at withstanding yield. So one thing that was sort of a nice sort of case study for us is 2012. You can basically look at the model that we did before 2012 rolled around, and then estimate what happens in 2012 with that model out of sample going into the future. And it was really right on. We sort of predicted very accurately this negative effect in 2012, suggesting that at least in 2012, the crops were just as sensitive as they were in the sample period we used to calibrate this model. Now, here's sort of a thing then what happens with climate change going forward, and a bit of a puzzle that I'm going to allude to the next. So what you see here is in red, on the left axis is average temperature, on the blue axis is this extreme heat above 86 degrees Fahrenheit. You see 1936, which was bad in average temperature, but it was really brutal in terms of extreme heat, and that was the Dust Bowl, where sort of people abandoned farmland and sort of moved away. Again, consistent with this idea that extreme heat is really super bad. You saw 2012, which was an episode here. And you see how climate projections in light blue are predicting that this will supposedly take off until the end of the century. So we're going to see really strong increasing trends. The bit of a puzzle is, if you look at the actual realization, is that they haven't perfectly aligned with what the projections say they should. If anything, the last few years have actually been good, except for 2012. There's even a slight decline in the amount of extreme heat. And there's a bit of a sort of puzzle why it hasn't warmed more over the US Corn Belt. And it's definitely different from the rest of the world. So there's areas in the rest of the world where it's much more. And that's sort of a current working paper I have where we basically look at the effect on the feedback of agriculture on the climate. And the study setting here is basically the Ogallala Aquifer. It covers like 8 states. It's a underground aquifer where the water flows from the north to the south. You see here color-coded what happens to irrigation over time. Nebraska has seen a big expansion basically between 1959 and 2017, while the northern panhandle of Texas, which originally irrigated a lot, sort of the water table dropped, and they've actually seen a decrease in irrigation. So we have both an increase and a decrease. And so what we then do is we look at what happens to temperature trends in those counties, in those more than 300 counties. Here, each bubble is basically a county. They're color-coded, so the red ones are the ones that basically saw a decrease in irrigation. The blue ones are the ones that saw an increase in irrigation. And the size of the bubble is proportional to how big the upwind county is being irrigated. And one thing that immediately pops out to you here is, or should, that if you look at the summer months, June, July, August, the blue dots see much lower increases in temperatures than the red ones do. And that's basically when you turn on irrigation. So there's this idea that if you irrigate, it's basically like I've been to Phoenix, Arizona, and if you sit in a restaurant, they put on the sprinklers to basically cool you. It's basically in a large scale what happens here with the agricultural fields. If you do this pivot irrigation systems, where you basically flood the fields, the evaporation then cools the downwind areas. And that only happens in the summer when ag is grown, but it doesn't happen in the winter months. So we can sort of test that more formally, looking at what happens areas that irrigate versus areas that don't irrigate, what happens to the temperatures downwind, whether it's crosswind or upwind, and what happens to different parts of the temperature distribution. And so as you would suggest, the green one is basically the downwind area. The green one is downwind from irrigation, so it's basically irrigation that's upwind. And so you see there's this large drop only in the summer months when irrigation takes place. And this is the 99th percentile, so this is the maximum, this is the extreme heat. And as you might expect, if you go to lower temperature percentiles, like the 5th percentile, there's less of an effect because the irrigation is mostly, evaporation, and all this happens when it's hot and during the Tmax of the day. Now that then has sort of several effects. We basically sort of look at the effect of irrigation by basically making downwind cooler. We use two things here. One is sort of the effect of irrigation on yields. You make yields yourself. That's the direct effect, less acceptable to heat if you irrigate. You get the indirect effect downwind because they basically now have less exposure of extreme heat. So that's a benefit. And you also have actually less heat downwind, and EPA has those estimates of how extreme heat impacts mortality. So you can use that statistical value as well. And then what you see is sort of that the economic value of irrigation is the indirect effect downwind are about the same order of magnitude as the direct effect of the farmer who irrigates, as the combined sum of yield gains downwind and avoided mortality. So this also suggests, sort of going back, is that extreme heat really impacts yields, but then agricultural practices also really impact the climate, especially downwind. Now, the US has sort of not seen this big climate trend, and irrigation is just one factor. The other thing is sort of the decadal oscillations and other things that sort of contributed to it, but they're a bit of an outlier. This is sort of earlier work I've done with David Lobel at Stanford and Costa Roberts, who was also at Stanford at the time, a grad student. And this basically plots the trend across the globe. And again, here you see that the US is sort of some red, some blue, so there isn't really a strong trend. While if you look at Europe or other regions, you see much, much more significant trends. So this is basically in terms of historic standard deviation. So this is 3 standard deviation of historic temperature variability. So this is very strong warming trends here, while we haven't observed them in the US as much yet. This sort of then points, can look at this sort of statistically. I mean, if you do any time series and you fit a trend, sometimes you will see a warming, sometimes you will see a cooling just by chance because weather varies year to year. So this is basically plotting 1960 to 1980. The gray one is basically if you do just random draws from something that is variable. So you find some negative, some positive, and you look at the observed trends across the area where the 4 basic commodities are grown, and they're pretty similar. But now you go from 1980 to 2008, and you see this very strong shift to the right of the observed temperature areas over where the corn, wheat, rice, and soybeans is grown. And you see that they on average have about a 2 standard deviation, almost 2 standard deviation increase in temperatures. And actually then in another paper, we sort of then shown that these increased temperatures also basically capitalize into weather futures. So you actually have at the Chicago Mercantile Exchange a contract where the payout is a direct multiple of the observed weather at weather stations at airports all over the US. So you can basically, a lot of companies use this as a hedge, but you can basically bet on the weather. So if you're a climate skeptic, you could in principle say, oh, this is all a hoax, it's not happening, but then you should really go short on those contracts because their value has gone up because we have more extreme heat, and you would have lost a lot of money. Those contracts basically have the climate models correctly placed in and the real observations really fitting the history of what we had since 2000, since the market sort of became liquid. So it's basically the market sort of seems to agree with the climate models. If anything, they're going for the more aggressive warming scenarios that they're pricing in. Okay, a couple of extensions of this. So something that economists really care about is sort of this, what we call elasticities, is basically if you shock something, how does it respond? So it's like the quantity change in respect to a price change. We looked at it in the agricultural market. It sort of has implications that basically what happens to any kind of disruptions like the biofuel mandate, or like we had a supply shortage because of a weather effect. And basically the takeaway from that paper is that supply is about twice as elastic as demand. And so basically 2/3 of the response to basically get the market back into equilibrium comes from supply, while 1/3 comes from demand. So specifically, an important implication is, the US has the biofuel method, which is currently mostly based on ethanol, that diverts actually quite a lot of calories out of food into fuel. And about 1/3 of that comes from demand reduction because we lose less of those calories for food. The other thing is sort of that colleagues here have done a follow-up papers in terms of adaptation, again, emphasizing this role of extreme heat. They basically look at how different crops had different exposure to extreme heat over the last decade, and then basically find that the ones who had the largest exposure subsequently basically have the most innovation and have new patents trying to sort of help the plant. So there's a bit of adaptation possible here. The other one is about storage markets. So one big implication is that the FAO is really worried about food price volatility. We've seen this, with COVID lockdowns, then prices shot up, and then Russia's invasion of Ukraine, then it came back down, and then came back up. And so that's sometimes very detrimental for smallholder farmers because, if the prices collapses and they invested everything in their field, it's very hard for them to recover. So one thing there is we sort of show how important storage markets are to smooth those shocks. And if climate change basically implies more volatile yields, you can really buffer against this increased volatility by just having a functioning storage market. So one thing that makes me worried about this, how good storage can work, is that we have this recent political economy where countries are sort of putting on trades and tariff restrictions to basically disallow free trade, which has been used to average out shocks in particular countries and also basically give an incentive for storage to then basically deliver food to areas with higher prices when they sort of really need them. And so there's a really nice paper sort of showing here again by colleagues how trade policy responds to, again, extreme heat-induced weather shocks for crops. So one example here is, again, the Indian wheat export embargo. But in generally and consistently, they find across the globe that the agricultural policies, how we basically regulate markets, are very pro-consumer in response to extreme weather shocks. And that obviously then takes away the incentive to store. If you know that, well, if bad weather shock hits, I can't really take full advantage of this potential to then export it. People might store less and therefore make us less resilient to those shocks. The other thing that Aaron mentioned quickly at the beginning is that in some work we sort of linked this. People before have sort of linked the effect of temperatures and ag on local livelihoods. And so we basically got the EU asylum application data for like 23 years, and we basically look at the origin of where they come from, and we look at the weather over the agricultural growing area. And it's not just the weather directly, because if you look at weather over the cities, there's no effect. But if you look at the weather over the agricultural growing area during the time that the stuff is grown, you see that if they have extreme heat, if it's very hot, that then in the asylum applications go up, and the approval rate actually goes also up because they can sort of document that they've been in distress. And then lately, there's some work here also emphasizing the interplay of soil moisture with extreme heat. If it's basically very hot, you usually don't have a lot of water because otherwise, again, similar to the previous example, the cooling would basically come from the evaporation. I want to conclude with another sort of ongoing project that I'm sort of excited about. We've had those phase experiments where we basically pump CO2 into fields to see what the CO2 fertilization effect is. This is often under sort of idealized growing conditions. And so a colleague here, Charles Taylor, and I wanted to know whether we can observe this in real world growing conditions. So you see sort of here this green revolution graph in green of corn yields again I showed you before. And then in blue, you see sort of what happens to CO2 levels. And yes, as CO2 takes up, also so do yields, but they're both trending. So it's very hard to sort of infer whether one impacts the other. So there is sort of this cool new satellite that basically NOAA put out, OCO2, that basically gives you measurements of CO2 through time and space. And you sort of see here how there's sort of, certain eruptions from volcanoes, and there's other sort of events that sort of lead to or releases from like, power plants or anything. But it leads to small deviations over time that then sort of spread through space. And so we can basically then look at and link CO2 anomalies and how they vary in space and comparing them to sort of what happens to the yields in space over time as well. So Professor Goldberg and I live close by to each other here. I'm here in the office. He lives close by. And so basically the idea is if, Ray gets a little bit more CO2 than me on a particular day, is his growth on that day larger than it usually is compared to mine. And so this is, you see here, there's sort of this big variation in space. So we usually think it's a global pollutant, but there are sort of these anomalies. And we do find a very sizable CO2 fertilization effect that's sort of on the upper end of what phase experiments had suggested. Okay, finally, I'm running out of time here, but another thing is, so extreme heat predicted to go up, especially if those local cooling sort of stops for big breadbasket like the US. And with climate change, we sort of have some pressure put on the progress we've made in sort of feeding the world and having more food availability. So one question you can ask is, well, the World Bank and the IMF go to countries all the time and say, like, you have a yield gap, you have institutional barriers for people to optimally invest and basically get the highest yields. So can institutional reforms actually deliver those yield gains as the IMF and the World Bank advocate? So one thing we did here is, again, using remote sensing, we now have satellite-based measures of yields from all over the world. So what you see in the left here is basically South Africa and Lesotho. Lesotho is this country that's completely surrounded by South Africa. It's not that easy to see in the aerial image, but you see sort of the green irrigated fields on the left side in South Africa. And on the right side in Lesotho, you don't have sort of the same irrigation and same productivity. So what the right graph basically shows you is sort of then this, EVI index, which is sort of a proxy for yields. And you sort of see how they're changed discontinuously at the border as the sort of, economic policy regime changes. So what we do in this paper is we look at all borders and around all borders of the world. And in each year, we look at the discontinuity and how much they vary. And they vary for many factors, for cultural norms, for like endowment, anything can sort of vary around those borders. But what we then do is we again sort of look at over time. So if a country has a reform, does its differential at the border to the neighboring county start to change after you instituted a reform? And that's sort of what we find here. So what we use here is this Fraser index. That's something political scientists use to sort of measure economic reforms. And so 0 is basically you're very restrictive. That's sort of Venezuela. And then Switzerland and the US is sort of almost close to 10, to like a free market economy. And you do observe that if you increase the Fraser index from 5 to 6, there's an increase in the border discontinuity in the year after. If you go from 7 to 8, there's even a larger. So meaning once you have a lot of deregulation, there's a larger increase that's sort of up to 2%. And then what you see now here is basically including additional lags, because you might say, well, if you do an economic reform, I don't see the benefits right away. I have to wait like a couple of years until people invest and sort of come up with new technologies. And so not surprisingly, this slope becomes steeper, meaning you have higher yield gains. So that sort of suggests there is a potential that, economic reforms that IMF and World Bank advocate can boost yields and sort of close to some extent the yield gap. There comes some caveats though as well. We then sort of also lose remote sensing data on forest covers. And we do find that as you become more productive. You also increase your growing area, which often comes at the cost of basically deforestation. Another thing we don't measure is sort of additional nutrient runoff or fertilizer runoff. So that's sort of another caveat. All right. So to conclude, we've talked about the beginning. I tried to say how human history has intrinsically been linked with agricultural production and weather. We still have this dependence on weather. It doesn't go away. We still are sensitive. Extreme heat seems to be a main driver of basic commodity crops. We did make some progress. We have higher availability now than we had for pretty much most of the history, but there seems to be additional stressors. While CO2 is a beneficial effect, that one is diminishing with CO2 rising further, while extreme heat is starting to accelerate with continued warming. So there seems to be some strain put on the system, but we also have some policy levers like, I'm a big advocate for free trade, because especially in the agricultural area where we have idiosyncratic shocks in one particular country, it's very important that you can hedge, you can smooth them out across space and also give the right incentive for storage. And we can also do some political reforms to basically help close the yield gap in some areas which currently don't have the same yields as the US has. I'm very much looking forward to your questions now. Thank you.
Thank you very much. I think Eleanor and I, there she is. Perfect.
Perfect. Thank you. I feel like I've had, a year's worth of agricultural economics in half an hour. Thank you very much. So I'm very interested, as someone who's an alumni, what is or should the role of agricultural economics and policy be within the Harvard ecosystem? What is your vision for what you are looking to do with your new chair?
So I'm very pleased that Ray is on here. And, I think the chair came about because Ray, for many years here, has built an amazing community across campus that sort of highlights how interdisciplinary and interlinked the whole food system is. So the chair is named, a professor for the global food system that actually doesn't sit with the Kennedy School, but it sits with the provost office. So one thing I think from my own background, I started out in engineering, then veered over to sort of economics. I like to work across fields. I'm very excited about initiatives that are going on here at Harvard. There's people, Peter Hybers over is doing a lot of interesting work as well. Forrest Reinhardt over in the business school. So there's a whole ecosystem here of people looking at this very interdisciplinary problem from many different angles. And I think that's what we need to do to solve it efficiently. Since, Hayes is on here as well, I'm also very excited to cooperate with the Salada Institute, which sort of similarly has the incentive to bring researchers across campus together to work on climate and sustainability related issue, and ag is one of them. So I think this is sort of where I see myself. I've been like a kid in a candy store, meeting people from all over, also from public health, with Willett having the planetary boundary report that came out in the Lancet. So there's just a lot of amazing people working here. And I hope I can act as sort of a bit of a focal point and bring people together and sort of raise the visibility of this issue. That's sort of my things I want to accomplish here.
Wonderful.
Thank you.
So I have a slightly more technical question from the audience, and I'm going to add a little bit more context because it's similar to one of the questions that we wanted to ask. So Professor Schlenker, you mentioned the impact on yield, and just to kind of unpack that a little bit, are you in your research looking at the impact of yield, but also, we talk about the quantity of calories and yield. What about the quality of the yields and things like protein content as an example? And similarly, in terms of the nuance, in terms of what you're looking at, one of the questions from the audience is, how do we, so he's in the summer of 2012, I'll just say it, a lot of the Corn Belt suffered from an extreme drought in addition to high heat. And he's mentioning that, he saw corn plants in Nebraska kind of shrink into almost the size of a pineapple. And so similar to what I was asking in terms of the quantity and the quality of protein, question from the audience is, how do we differentiate, or do you differentiate in your modeling the impact of heat on yield, but also differentiate from the impact of drought on yield?
Yes. So two very good ones. So in the research I've done, it's predominantly just been on quantity of the calories. So it's not, in one of the qualification slides that I didn't go over, I guess, enough depth, is that, yeah, one big thing that we don't really do here is sort of at all looking at a balanced diet. It's just sort of, do we even have enough of the basic calories to feed the world? But again, Willard sort of is who's here at the public health school. Many people here at Harvard have emphasized, obviously, that nowadays the quality of your diet is just as important as having a diet, especially in developed countries. We see more and more people who basically suffer from malnourishment, not just from undernourishment. And so there's research being done in this area, but I haven't contributed much into it. And I know there are some studies which look at sort of the micronutrient content as a function of climate. And if anything, there's also additional worry that with extreme heat, you actually also lose some of the micronutrients. That's sort of the first question. So very important point. It's not one of my focuses, but I think if anything, it most likely even amplifies the stressors. There's been some Nature papers sort of looking at the content. And Missy Holbrook, who's a professor here in biology, is actually a paper on this, how the nutrient content is going to decrease with climate change. So important point. Now, trout versus temperature, very important topic. So we always control for precipitation too and soil moisture. There's different thoughts here. Now, they're really they're really highly intricately interlinked in the sense that it's true that if you talk to farmers and you ask them what is the reason for why you have a yield loss, the predominantly large share of people would say it's a drought. But drought is a relative concept. Drought is basically you have a water shortage for whatever the plant wanted. And as it gets very hot, your water demand goes up. And so therefore, what we measure with this extreme heat is basically, and then I talked to you about the cooling effect of water. So if there's water in the soil, it basically evaporates and cools it. So the reason for why this extreme heat is such a good predictor of yield decline is it basically indicates a situation where the plant wants water a lot, but it's not available because if it was soil moisture, then you basically would have had not as high of a temperature because the evaporative cooling would have sort of put down the temperatures. So that's why it's this really strong signal. We've done studies, faster extreme heat comes back better. We have can show you some additional slides there. I partnered up with some crop modeling community. There's sort of a big effort there too to sort of replicate predicted yields under various climate and other conditions. And they also find this really strong effect of extreme heat. So I think extreme heat is a better predictor and more severe for crops because it's sort of this indication of this double whammy that you want a lot of water, but you don't have it. And so my co-author, David Lobel, also likes to tell the story how drought conditions in the Southwest, so he's at Stanford, have gone up over time, even though precipitation has remained constant, but it's just that it's gotten warmer. So it's a relative concept, and that's sort of how I come down. Finally, sort of as an example, in 2007, if you ran the Chicago Marathon, they ran out of water. Why did they run out of water in the 2007 marathon? It's because it was a really hot race day. And again, it sort of shows you the relative concept of water demand. When it's very hot, you want to get a lot of water. So under normal water condition, they ran out of it. So that's, I think, why extreme heat is such an important predictor. Now, there's one qualification, though, that Peter Hybers and others are really emphasizing and stressing. And that is with climate change, because it gets warmer, the air can hold more moisture. And there is an open debate whether with climate change we're going to get actually wetter or drier. I think my reading is the majority of natural scientists think it's going to get slightly drier, but there are some who actually predict that because the air can hold more water and might have been more extreme precipitation events, it might get wetter. Now, if it gets warmer and wetter, that would then change the equation a bit because then we no longer have sort of this correlation with heat and water, and that would mitigate it a little bit going forward.
Thank you.
So you mentioned your 2009 research on the impact of heat on yield. And as I remember that you were looking at primarily at corn and soybean impact, and with the outcome from your study that the predicted impact on yield was anywhere between basically a third to 2/3. by the end of the century with expected temperature increases. So this is an enormous impact. What do you predict the impact is going to be on prices?
So the one little qualification, just to put this into context, I've shown you like this really strong trend, right? How we've gone up sixfold. The prediction of this impact is net of that trend. So we're not saying that we have a third less than we have now. We're basically saying we have a third less than we would have had if we hadn't had the warming. But we still have sort of this strong warming trend, which over the next 80 years or something is likely going to go up because we've had sort of this, biotechnology giving us higher yields. So just to put this into perspective, this yield decline is relative to that trend, not like an absolute decline, which would be really horrible. Now we need more calories because we still have population growing a little bit. As countries get richer, they basically want a more meat-based diet. And so I think that's going to determine that we need more calories. Now, in terms of the effect of prices, I think there's going to be, so this was the study looking at the US and holding things pretty static. So I think my prediction for the future with this warming, if we don't mitigate and it continues to, it is sort of twofold. First of all, it would lead to a big reallocation of the bread baskets around the world. The New York Times had a fascinating story about 4 years ago, how basically people are starting to strategically buy up. It was before the Russian invasion, so it might have changed a bit now. But they're basically strategically buying up farmland in northern Russia, which is currently permafrost, or sort of starting to thaw. And if you have this high warming, you actually might have an area like that that has really good soils. They might become sort of what the US is right now. The US right now is some of the best soils because under the last glacial expansion, we sort of scraped it off Canada and pushed it down to Iowa. And that's sort of this really nice, rich black soil that they have there. Russia has it too. They currently can't utilize it because it's too cold, but they most likely will get better growing conditions. So some of the yield decline in the US could potentially be picked up by other countries like Russia. That's sort of, I think, one of the mitigating facts. The other big thing is sort of then the price signal and the feedback we get. I think meat would become more of a luxury good because meat as a diet is basically, needs a lot of calories to grow the cows. And then I guess the big other thing you have to model in sort of the interaction, what happens to other sectors is what happens to inequality around the globe. If we continue on the current trajectory of pretty, unequal societies, I think we would just have certain parts of the population struggling with the higher prices, while for other countries, it might not be that big of an increase because the raw commodity prices for US diet isn't that much. But if you live on like $2 a day in Africa, then if your commodity prices double, it's a huge thing. It's like eats up all of your income. So it would just really exacerbate income. But obviously, we're talking here end of the century. Economists are notoriously bad. Like Malthus was very bad in his prediction. So I think I don't want to be the doomsdayer. I don't want to be here saying like everything is going to go bad. I think what I want to do is sort of similar to Malthus. I want to alert, similar to the call that we've seen of this 150 people. I want to alert of what the consequences would be under unabated, climate change if we don't start doing things about it. I hope we start doing things about it. Like we have really decreased the amount of funding we have for like crop breeding programs that have huge positive spillover. So companies might not have the full incentive to innovate. So I think we should better invest in this. The Gates Foundation has pushed in that too. We should like look for new production areas so we can sort of buffer some of those declines. That's how I would like to see my results.
Wonderful. I'm working through some of the questions that are coming through. You mentioned crop breeding, Wolfram. And so in the plant biotech world, and many people on this call will probably appreciate this, oftentimes people frame these things by genetics, environment, and farm management. And those three different areas kind of are interplay in terms of the impact it would have on the outcome. So one of the questions from Pete Vegas is, you mentioned the cooling effect of irrigation on yields. Of course, water has a big impact. And his question is, has anyone studied how much of the yield increases actually came from irrigation, especially when you think about aquifers and depletion of aquifers? So yeah, the question is, has anyone studied how much the yield increases have come from irrigation in this instance?
So I guess there's two things to it. So One thing people have studied how once you can irrigate, you can buffer much more against the shocks. So yes, we have estimates about how extreme becomes less damaging when you have irrigations. There's another question though embedded here is like, if you permanently switch to irrigation, how does this actually change sort of your productivity on average, not just at withstanding shocks? That is harder to estimate because usually when people adopt big irrigation systems, they also have other changes, new crop varieties, things like that to figure it out. But that has boosted yields as well. So, there are studies by FAO sort of arguing that irrigated agriculture is much more productive. The big fear there is that we basically using water at a non-sustainable way right now in many parts of the world. In India, they've been pumping the groundwater dry. So we have an incoming colleague here, Shanad, who's currently at the at the San Francisco Fed, who sort of studied water trade and agriculture around the world. And he sort of looks at how the embedded water in agricultural goods and the trade and what the implications are. And his findings are actually kind of, at least for now, positive in the sense that the US is highly competitive in agriculture. I showed you earlier how much of a share they have. And they are also more efficient in how they use water than others, like India. So shutting down, some people have pushed against agricultural trade, saying like, "Oh, you're basically exporting your water with the crops," but that's not the case in his model. It's actually that the more efficient countries also use the water more efficiently, and therefore the trade actually mitigates some of this water extraction. But so yeah, it has an effect. I think it's larger on reducing the detrimental effect of extreme heat than it is sort of giving you the average growth effect.
Thank you. Thank
So
you.
as kind of a follow-on question to that, we have a question from the audience. Are there any projects or studies that have looked at the impact of soil health practices that increase soil hydrology, like cover crops or no-till on heat?
Oh, that's an interesting thing. So there are studies that look at, one of the ways why we actually achieved higher yields is that we plant corn much closer than we used to, because now the tassels are going more, straight in the air than sort of horizontal. And as we have more plants, they all sort of evaporate. And so if you have more biomass activity, you evaporate more. So just like the crop growing, people have shown that this has a cooling effect too. In terms of the soil, I haven't seen many. Now, to be clear, we find it because we do this in a very inefficient pivot irrigation system. If you look at Israel, which has like very, very high tech, because they're very water constrained too, like drip irrigation, you wouldn't see that much of an evaporation of the irrigation. So it depends a lot on the irrigation too. But I haven't seen, short answer, I haven't seen a study on like soil management on the feedback on the climate. People have looked at productivity and other things, but I'm not aware right now of one.
Thank you.
I know we're coming up close to time, so I want to be respectful of your time and everybody else's time. So I'm going to ask a pretty loaded question.
Thanks.
But it's a nice one, I promise.
I have a follow-up loaded question too. So
okay, I was actually going to ask, and maybe Eleanor, you can decide if you want to answer yours first. But you
go.
have between both of our alumni groups, there's about 5,000 alum. We have a great group of distinguished people joining us today. And so the question for you is, how are you interested in further engaging us? How can we further engage you? How do we work together?
So I think there's sort of several avenues. The first one, as I said, I'd love to be a focal point, sort of ag related, because there is already a lot of activity around campus in this. We just need to bring people together. So one thing I'm doing, and this is an open event that anybody can attend, is sort of we're having a Food Plus conference on May 2nd, which is mostly among academics across the Boston area, but especially also within Harvard, something that Bill Clark actually did in 2017 already once, is sort of to foster more of the community. That's just here within, but it's open door if anybody wants to sort of come. I mentioned at the beginning how I have this interdisciplinary class in food policy. I'd love to bring people in, and again, some of the audience is already generously volunteering the time. I'm also always open, very happy to meet with people and engage with them. I love to learn from them. I know there's been several case studies that have been written based on experience in the real world from graduates from Harvard. When you send out this invitation, I already got some emails from people sort of suggesting whether we can meet up. So if you're in the Boston area, I'm very happy to meet up. I also hope that in the future, through some alumni, any kind of alumni event in the future years, we have the possibility to sort of meet again on campus. That's to be determined, the exact format, but I would very much welcome that. I think I notice now, and I think, the students who currently take the class, the thing they're most interested in is sort of learning from the practitioners, from the alumni network, sort of what they learned, what they found interesting, what helped them advance in their career, what sort of their findings are. And so this sort of bridge between alumni and current students is something that would be fantastic sort of to elevate.
And just in response, HACE is focusing on this year developing programs around supporting students and recent graduating students to enter into disciplines related to climate. So that could be, something that dovetails.
Thanks. It's a good idea.
So this was my incredibly loaded question. If you had your magic wand and you could put in the 3 biggest changes for the next farm bill, what would they be?
For the farm bill. All right. Well, the unique thing about the farm bill is that it also includes SNAP, right? Which is sort of a food assistance program. So the last administration started under the Inflation Reduction Act. We had $19 billion for climate smart agriculture. And I think part of the reason for why the farm bill was because it was supposedly passed in fall 2023, then it was extended to fall 2024, and then it was extended temporarily again too. I think the 2 sticking points from what I can hear from Capitol Hill is A, SNAP, because it's 75% of the farm bill. That's a big chunk. And B, what do we do with the climate smart agriculture component of the IRA, and can we reappropriate some of the funds? So in terms of what the holdup was and where I see things, this is not really related to my talk today, but given how important food stamps are for making sure people are fed, I would argue that we should keep the SNAP program. It's a crucial program. There is an abundance of evidence from colleagues that sort of in economics and political science, how it has huge returns long term. If you invest in nutrition, you asked earlier the question of nutrition. If you invest in nutrition when kids are young, it has a long-lasting effect that basically lasts their entire life, and it actually has a positive return in an investment in the sense that they later become more productive and pay more taxes and so forth. I just think that's a very important, not just for moral reason, also economically, just a very good investment. Now, given the talk today, I think there's some quibbles about what is actually climate smart agriculture. We had Wildsack here and other people. I think it had good intentions, but they were sort of writing the rules as they were rolling out the program, which is often not very good, and sort of used this amount of money, the 19 billion, and sort of deploy it in the most optimal way. Obviously, I think they should use some of the money. They should think about what is the optimal way, how we can actually innovate. I mean, agriculture is, an important part in a lot of the red states. I think they're going to feel more and more, even under the new administration, what's going to happen with climate change. As I said, we haven't seen as much of a warming as projected so far. Part of it is sort of also the Pacific and the Atlantic oscillation and sort of the phase, and that's sort of what people sometimes call it the warming plateau. But it will pretty surely pick up, and they will feel it. So it just seems like a very wise investment to do this. You can quibble a bit about what's the optimal way, how we should sort of, give the optimal incentives for innovation and so forth. But it should definitely be part of the farm bill, in my opinion. So SNAP, farm bill, the climate smart agriculture, and then third, this also goes into the administration. I mentioned this briefly before too. The US is very integrated agriculture. It's a huge net exporter. So when we talk about tariffs, the current administration, the incoming one, always emphasizes how they have a stronger hand because they import more than they export. agriculture is actually the big exemption there. And during his first term, it was the Secretary of Agriculture who sort of pushed back against tariffs because the retaliatory tariffs will most likely hit agriculture pretty hard. And we're very integrated with, a lot of the fruits and the healthy stuff come from Mexico. So trade is very important for both countries to make them better. And I think, as I mentioned earlier, agriculture is also unique because we have weather shocks more than in any other sector. If you say, I want to put 100% tariff on Chinese electric vehicles, that will lead to the fact that we don't have much trade in electric vehicles, but you can build electric vehicles in the US and you can build them in China. And might not be the most efficient way of doing it by not trading, but every country can do that. If you do this in the agricultural context, it's much riskier because then each country has weather shocks in particular years, and we need to trade to sort of arbitrage those things, not arbitrage, to basically smooth out those shocks. So I would very much, it's my third recommendation, encourage them to lobby strongly for an open markets, because it's very important for countries which are food importers to basically make sure that we don't have those extreme events which are becoming more frequent, wipe out crop production and really negatively impact countries. And to be clear here in COP28, they had for the first time the Declaration on Sustainable Agriculture, where they exactly emphasized this in point 5 on their policy implication that they will work towards free, open trade and none of those export restrictions. So that I think the US should sort of reinforce that.
Thank you. Thank you. And
Wonderful.
we are up against our time. Thank you very much for joining us today. It has been a real pleasure. I feel like everybody here must have learned as much as I have, I hope. So I am very grateful for you joining us. We're going to make the recording available. We will send a follow-up email, and we'll also be asking about other ways that we can present programming on related topics of interest and for feedback on today. Thank you so much.
Thank you very much. Bye-bye.
Thanks so much for having me.
Thank you.